Hello, everyone, and welcome to our next session. I have Jay and Cassidy here from Centrifuge, who are going to be talking about building privacy preserving NFTs on Substrate. I'll let you both take it away from here.
Thanks. Hi, so I'm Cassidy, and I'm working on token design and research at Centrifuge, where we are building a decentralized asset financing protocol. I'm going to start with a short introduction today, and then I'm going to hand it over to Jay, one of our Rust engineers at Centrifuge, and he's going to dive into his work building privacy-preserving NFTs on Substrate. So at a high level, Centrifuge is allowing businesses to exchange business documents, such as invoices, and tokenize those assets to access financing. So the foundation layer is our peer-to-peer messaging protocol, and it's for storing and exchanging documents. Centrifuge chain built on Substrate provides the single source of truth for all of the parties involved using on-chain identities, document anchors, and our focus today, NFTs. Centrifuge chain is bridged to Ethereum and our securitization dApp called Tinlink, which allows investors and borrowers to finance their own asset pools using these NFTs as collateral for loans. And Tinlink smart contracts are open source and integrate easily into the DeFi ecosystem. So a brief look at how this whole system kind of comes together. So a company such as Paper Records, they use the Centrifuge peer-to-peer network to sign and send an invoice to, say, Spotify. Spotify verifies receipt of this document and its correctness with its signature and sends an updated and signed version of the document back to Paper Records. Centrifuge chain is used for the node identities, so that allows Paper Records to look up Spotify when they want to send this document, and it also allows Spotify to verify Paper Records. So then Paper Records is able to anchor this document hash with both signatures onto Centrifuge chain. And then using all of these elements here, Paper Records can now mint an NFT, currently at the moment using our bridge to mint this on Ethereum, that represents the unpaid invoice and uses NFT as collateral to access financing. So Centrifuge is a system to safely lend against real-world assets so that businesses around the world can tap into this new source of capital. So with Centrifuge chain and Tinlink together, any business can now originate their real-world assets on-chain as these tokenized NFTs and access liquidity through Tinlink pools. So today we're going to take a closer look at how we are building these NFTs on Substrate. So for our use case, our NFTs have business logic that is customizable for each asset. And we need a few pieces of customization for these different NFTs. So that includes metadata that can be read on chain and is validated from off-chain proofs, being able to check restrictions and enforce business logic, for example, like the amount of the loan, the amount of the invoice, the due date, etc., and be able to validate signatures of the collaborators. And finally, for our use case, the NFTs must be privacy preserving. So now I'm going to pass it over to you, Jay, to dive into some more details about our NFT palette on Substrate.
Okay, thanks, Cassidy. So basically, I'm going to talk a little bit about the NFTs and like how they're actually implemented on the Centrifuge protocol. And then I'm going to get into some of the design philosophy that we tried to integrate when designing our NFT palette on Substrate. So first of all, this right here is a Merkle tree. So NFTs in Centrifuge are represented, they represent documents, and a document is encoded in a Merkle tree. So you can see in this Merkle tree that the leaves are the fields of the document. And so in this example, it's an invoice, and you have an amount of 51,000 and a supplier that's tier LLC. So you can think like, if I'm the owner of this document and I want to upload it to the chain, I may want to provide the information that the amount is 51,000, but keep that the supplier tier LLC, keep that private so that that's not on chain. So basically, an NFT holds the Merkle root of the document. And when you're minting, you can supply, say, like the amount 51,000 plus all the other hashes necessary to generate the Merkle root. And in doing that, the chain can actually, the runtime can verify that the Merkle root matches the anchor. And you can basically, as the owner, prove that you know certain information about the document and keep other information private. So that's how the NFTs work as Merkle trees. Next, I'm going to talk about some of the design philosophy for the palette. Yeah, and if you have any more questions, you can also go to Discord. Sorry, I'm probably not going to address the side things. So yeah, we were really interested in starting the work towards creating a standard for non-fungible tokens on Substrate in general. But you know, you have to ask yourself, is a palette like where to start with that? Because there's a lot of NFT palettes already being worked on. There's Dan Forbes created the commodities palette. The Unique Network is doing an NFT palette as well. So you have to ask, is a palette general enough to conform to a standard, and can one palette rule them all? So I think there's three big design decisions that go into creating a palette and like what you want that palette to represent. So the first one here is storage. So it's everything that goes into the declare storage macro. And this basically means that a palette has state. So this off the bat tells you that, you know, a lot of different interfaces can implement different kinds of storage. So you can have, you know, NFTs that all implement the same interface, but you can have 1,000 different ways of representing that data structure in storage. For example, you can optimize for the minting of an NFT, or you can optimize the storage for the transfer of an NFT. You can optimize it to index for accounts, or all kinds of different things, and they can all be NFTs. So yeah, another component that you need to consider when creating the palette is the dispatchable methods, which are the user interface. And it's easy to start here, but I think it's important to really distinguish this as almost like a side effect of a palette, because these are the endpoints for the user. This is everything that goes into declare module. And these functions, these methods don't return anything. They're just dispatchable methods for the user. They're not used for the composition of palettes together. And the third thing is the developer interface. And so this is everything that you're implementing on your runtime module, on your palette, all the methods that can actually implement traits and can implement interfaces and standards and things like that. And this is what other palettes are going to call. And this is where you can, you know, make your palette truly reusable and compositional and things like that. So this is the section that we really tried to focus on, because the user interface is kind of a separate concern for your specific use case. So in the next slide, we created a unique assets Rust crate, and this crate is basically just a set of definitions of what a non-fungible token, the properties of a non-fungible token. So we have unique, mintable, burnable, and cappable. It looks similar to Solidity. So for example, here you can see the unique trait, and this would be the closest resembling like the ERC 721. So you can see there's a transfer method, and it tries to universally, you know, encapsulate the idea of what a transfer is. So a transfer is something from a caller to destination account, and it's transferring an asset that's referenced by its ID. So interestingly, in the Centrifuge use case, and also as a design pattern in general, common for NFTs, is that an NFT is stored inside of a collection. So like in Ethereum, you have an ERC 721 smart contract. So the smart contracts are the collections for an NFT. Similarly, in Centrifuge, we have the concept of a registry, which holds the collections of NFTs that are just share some common minting validation logic. The unique network also has a concept of collections around their NFTs. So what this means is that an actual NFT on the chain is not just represented by a global asset identifier, it's actually represented by the registry and also the token. And so tokens can have naming collisions across registries or across smart contracts. So the global identifier in this transfer method here is trying to be universal so that we can encapsulate this design pattern on also all others. So if you look on the next slide, we basically just solve this by creating a product type inside our palette that wraps up a registry and a token ID into a global asset ID. And they can also be destructured back into their component parts. So in this way, if we go back to the idea of like the user interface and the developer interface, the user interface can still work in terms of the registry and the token ID. And the users, when they're using, the Centrifuge chain through the whatever apps, they can, write in the registry and the token ID or whatever needs to happen. But internally, we're using this common universal interface that is the global asset identifier. And also we have an asset ID reference type, which just allows for a zero cost abstraction, which is, we can thank Rust for that. Yeah, so this is kind of a universal design pattern that you can do for any kind of identifiers too. So here's the project layout for a chain, for the NFTs at least. And so you can see that we have an NFT palette, and it's a very minimal palette. In fact, all it does is implements the unique and mintable traits of the unique assets library. So it also exposes the transfer dispatchable method. And the reason it does that is because the transfer logic is not going to change based on any specific registry design or anything like that. A transfer is a universal concept across the Centrifuge chain. And so it's exposed at the NFT palette level. But the NFT palette is very small still. The only other thing it does is implements internally the mintable trait. And because it doesn't expose it, it allows the VA registry, which is the verifiable attributes registry, which is just a registry that allows a user to prove that certain fields of a document exist. So that has custom minting logic associated with it. And so we're able to use the NFT palette and do a thin wrapper with that custom validation logic and expose that minting method. It also exposes the create registry method. So in the future, when we have an Inc smart contract validation method, we're going to have a new registry for that. And on the next slide, you can see that it's going to be the same design pattern. We're just going to be able to use the internal mintable traits just the same, and we'll just expose a new minting dispatchable method. So the NFT palette has remained very small and is therefore very compositional in this way. And I mean, we found it to be a pretty good design pattern to create, reusable and compositional code. And if more people end up using these kind of things, then we can really start to share code and implement to common interfaces and kind of interchange these small palettes like this. So we hope that this becomes a common design pattern moving forward, and we can all share code a little better. So I didn't post any links to the unique asset trait or our NFT palette, but you can see those. I'll post them in the Discord too. And that's about it.
Great. Thank you so much, Jay and Cassidy.
Thanks, Jay. So I've got a few other links here. If you've got any questions, you can join us in our discourse or community Slack. You can check out the live pools on TinLake and try to break, use, and integrate with Centrifuge chain. I'm not sure if we have any time for questions right now. But as Jay mentioned, we'll be in the Discord chat and happy to answer any questions there.
We got 5 more minutes, so there's 2 questions here if you want to give them a go. So the first one is, I don't understand the link with the invoice. Is there an official state enforced law that forces companies to link the invoice with the NFT?
So basically, when you're using Centrifuge to send this invoice, this document back and forth, both parties are signing to the validity that this is an invoice, that this is the asset itself, this business document. And the NFT is then representing that invoice on chain. So it becomes kind of the legal backing for needing the buyer to actually pay the supplier back, if that makes sense. Hope that answers the question.
Yeah, and that's a cryptographic signature too. So that's part of that would be encapsulated in the Merkle root of the document. So you can always prove that the signers exist.
Cool. And then the next question is, regarding the precise proof slide, is there a reason why the hash on the right side has less data? More specifically, why are the line items in the invoice arranged in the order or hash groupings as they are?
This is a good question. I think I didn't make this diagram, and I think one of the engineers on the team mentioned that there might be mistakes in it and that there's an updated version. So if that's the case, then you maybe go look on the Precise Proofs GitHub page. It might have a more up-to-date visual. But I mean, in general, it's just a Merkle tree, and it's pretty straightforward, I think. But there's also some Medium articles where you can see more about the spec.
Cool. And then one last question. Oh no, we got quite a few came up. Here's one that got 2 votes in it. Is there a legal percent? Would a judge recognize this? Is there a legal precedent? Would a judge recognize this?
So this is something that we did investigate when we first started out, just with the concept. And it seems like there's precedents coming up to be able to recognize it. At the moment, we're just taking it a step further and creating a legal entity behind the NFTs to begin with, or behind these Tin Lake pools, actually, to be more accurate, so that there is an entity that's responsible in the case of an asset default, for example. So basically trying to build a structure that in and of itself doesn't need to rely on the judge as the fallback for every specific NFT. And that includes things like being able to have different risk tranches, so that senior investors don't have to take on this risk of assets defaulting, being able to then put that back onto a legal entity that's taking responsibility for that as an admin of a pool. And then hopefully the very last resort would be a judge, but putting as much in place as we can to make this a system that stands alone on itself without having to rely on traditional legal systems as the last resort.
Great, thank you. And then one more question. Is this the correct idea? I want to share a doc with Jay and have him sign it so everyone can verify he signed it, but not leak the details of the doc. So I submit the Merkle root on chain and Jay submits the signature of the Merkle root on chain.
So I mean, we all sign the document off chain together, and then somebody's going to submit the anchor of that document onto the chain. It doesn't really matter who it is because we both signed the document off chain. And then once the anchor is on there, or through whatever process that happens, then you have somebody mint it, and it's the same thing. You're minting with some proofs, and those proofs have to match the anchor Merkle root. So whoever's submitting it, it doesn't really matter because the signatures and the agreements are happening in the signatures of the actual document itself, which is off-chain. I hope that answers the question.
Great, thank you. So that's all we have time for questions. But you can join Cassidy and Jay on Discord if you would like to have some further discussion about this. Thank you so much.
Thanks, everyone.
Thank you.
Okay, I'll see you all in the next session.